So I have a control system and it is working. This is actually an accident though, as the controls are incorrect. And this is because I forgot my basic mathematics. I'm not great at mathematics. It's something that I work at and I do get by, but I'm far from being good at mathematics. And in this case, I was thinking about my mathematics in the way I usually use it within rigging, instead of the way the mathematics is actually fundamentally working. So currently I have a vector for the direction my character is facing. I then have a vector for the direction the character is moving in. And I'm projecting this vector onto the current direction for the character. I'm doing a full projection, and then I'm calculating the length of this projection. Although this is truly not really what I'm doing either, as I made a typo and my equation is actually incorrect. Doing a full projection is not really a bad thing, and it is mathematically correct, but it is also rather stupid. Essentially, I was forgetting the nature of the dot product. I've been using the dot product to calculate which direction this vector is facing. However, that is only a side effect of the dot product and is not what the dot product actually represents. The reason we can use the dot product to calculate the direction is because the dot product actually tells you something else. And what it tells you is actually what we really need. What I'm currently doing is I'm projecting the vector to get this projected length, but the dot product actually is this projected length. So calculating the full projection is not actually of any use, as the dot product is actually the projection in any case. We can use this for direction because this will give us a negative length when the direction is facing the opposite direction of the vector which we are projecting it onto. But once again, that is a side effect of the dot product giving us a projected length onto a vector. Essentially, if the angle between the vectors is beyond 90 degrees, we'll get a negative projection. When it is below 90 degrees, we'll have a positive projection. So I do not actually need to do any of the projections. And once again, the reason the controller is actually working is because I made a typo. And I'm not going to go into any depth into figuring out why it's working, because it shouldn't be working that way in any case. So the error which I'm making is in the projection equation. The projection equation is the dot product of u and v divided by the dot product of u and u multiplied by u. U is our vector which we're projecting onto, and v is the vector we're projecting. For my equation, instead of multiplying this by u, I've accidentally multiplied it by v. And once again, this is incorrect. I've now returned from my script, and we're going to correct this. I'll comment out all of the projection logic. I'll also remove the direction from the stick value. I want to create my horizontal and vertical floats, so I'll duplicate the lines where I made these, and I'll initialize both of these as 0. So these are the values which I'm calculating. I then want the two lines where I'm calculating the dot product. Currently these are being set with projected vectors, and these should actually be set with the stick direction. I can test these by logging them. I'll do this with debug.log. These will be placed in a string, and to add these to the string I'll add a $sign before it, and we'll pass the variables into the string between curly braces. I can now return to Unity, and we can test this. And we have values for the dot product. One thing to note about these values is they never get anywhere near the value of 1. In fact, both of these values approach 5. This is because I'm currently halving the value of my direction. I no longer want to do this, so I'll remove the multiplication from the end of where I set my stick direction. The next thing to do is update the values that we're adding into our animator, and currently these are being set with our horizontal and our vertical variables. I'll swap the order of these, because the vertical value is actually setting my forward direction, so I find this a little bit more intuitive. I'll set the vertical with my forward dot product. However, once again, my vertical is between 0 and 1, and I only want to be using this when I'm going forward. So we'll set that if this is greater than 0, we'll use our forward dot product. Otherwise, this will be 0. So I should now be able to test this. If I press the controller forward, I should move forward. If I press the controller backwards, I should stop. This is not working correctly. So the reversing of my direction was correct, and I'll reinstate that. This is now giving me a more predictable result, and it's more like what I wanted. We do not have a correct way of adding the 0 value here, and we'll have to take a look at that at a later stage. We can now look at the horizontal, and for the moment the horizontal will just be set by our right dot product. I can now return to Unity again, and I can test the movement of the character, and once again the result is the opposite of the desired result, so I am making a mistake in my setup. So I'm going to remove the negation again. I'm going to test and look at the values more carefully, as I want to see where my dot product is giving negative values. I'll negate the X value now. I can test again. This setup is now working properly when I run towards the camera, and when I turn the camera, we're running based off the direction of the camera. The camera will rotate around the player, and it will move relative to the player, and this is all being driven by the animation. So this simplifies my script, it gives me a more reliable setup, and it is more mathematically accurate. I can return to my script to clean up some things. Now that everything is working, I can remove all of these commented lines. I also do not need the projection function at the end of the script, and once again this is incorrect in any case, as this should end with a U rather than a V. I'll keep the debug drawing for the camera, and for the moment I'll turn this back on. We may eventually separate this so we can test more easily, but we'll survive with this for now. I'll remove the commented line where I'm setting the position, and that should be all the script needs for now.